part 1, my introduction. This is the introduction. We have that when you will try to do any kind of project in especially electronics, you have that you can work at several abstraction levels. In a company you will have probably some guy that will occupy himself on the lower level, some other will build on top of what the other guy made, and so on and so on. So this is a good way to distribute everything. Know that the lower you go on abstraction levels, let's say on the physics, for instance, the best you can optimize and have lower power consumption. And then you have the higher we go, of course, you have more higher abstraction, so it is easier to make ideally, but then you also have as a trade-off more power consumption, lesser performance in the lower cases, and then also lower price, because of course you have a bigger audience for FPGAs than for the guys that make everything in the ASICs department, application specific circuits. And then you have a CPU in which you do everything generically, very nice, and then operating system, and so on and so on. Everything you do, you lose a bit of performance when you go upstairs on these abstraction levels, of course. In fact, as an example, if you have applications that will run on specific kind of circuits, you have better performance than ones that will work on generic kind of, let's say, like if you have a computer, you have a same application, it will run worse than a box that does just that, of course. And the cost will be higher on your computer and will consume more, as I was saying. Then, also on the higher abstraction levels, there will be your C, your C++, your scripting languages as Python, etc. If we find that even on these higher abstractions you have several steps of course, more abstraction again, but easier to implement, and relatively slower, and the C that is more to the metal, so more performant.